Okay, now we learned about the measure of centers, right? Now we're going to learn the measure of a deviation. When we talk about the measure of centers, we talk about a mean, median, mode. Those are the most important measurement. And then when we talk about a deviation, in some book, they also call that dispersion. That means how wide the data spread out. Okay, and we're going to learn the following concept. The first one is a range. And the definition of this range is the maximum value minus minimum value. If you can think about what we learn in Algebra 1, Algebra 2, every time we talk about a function and there's a range, right? We have domain and a range. Domain is what x value can be, and the range is what a y value can be. However, in statistics, when we have the data set, when we talk about the range, the data range, that is the maximum value of the data set, subtract the minimum value of the data set, that will be your range. So this is a very easy concept. The next one is variance and standard deviation. Standard deviation. I have to say this is the most important measurement of the variation. Now, how should we do that? I can give you the quick formula and then I'm going to explain that, okay? For sample variance. Sample variance, we use S squared to show that. And the formula is summation, which is the sum of each x value minus the mean, sample mean. X bar is the sample mean. Okay, you square. So you're going to use each x value minus the mean, sample mean. You find the difference, you square it, and then you add up. So that's the numerator, and the denominator is n minus 1. This is the formula for sample variance. And for population variance, the formula is a little bit different. And the letter we use is a sigma square. That is the population variance. And that is a sigma each x minus the population mean. Square it, summation, and then over population size n. All right. Now, let me just give you a quick example about what does that mean. All right. So let's see. We have a data set. We have a 2, 3, 5, 7, 8. So this is a sample data set, and we have this little n equals 5. All right. Can you find the mean? Which is x bar, that will be 2 plus 3 plus 5 plus 7 plus 8 divided by 5, right? Because there are a total of 5 numbers. So that's 5. So we have the sample mean is 5 because the numerator, you add all those numbers up, you get 25. Divided by 5, you get 5. All right, now I'm going to show you how to find the variance down there. I list all the x values, 2, 3, 5, 7, 8. You don't really need to sort it from the minimum to maximum, but it doesn't hurt because if you don't have many numbers, you can just do it. And down here, you can write x summation is 25 and x bar equals 5. That's what we learned in the early sections. All right, now, if you look at the formula here, that is x minus x bar and then square. So what I'm going to do is for the next column, okay, I'm going to put what is x minus x bar. And in our case, x bar is 5. So that will be 2 minus 5, which is negative 3, and 3 minus 5, which is negative 2. Of course, you can just write down the number. You can write your answer here directly instead of writing the procedure. I'm just writing it so you can see what's going on here. All right, 0 and 7 minus 5, which is 2, and 8 minus 5, which is 3. Again, you don't really need to write all those. All right, now, here's the mean, or the x bar is 5. And we have some numbers below it, we have some numbers above it, right? So when you average the differences, when you add all those numbers together, you must have a 0. That's another way to check if you get all the differences correctly or not. If you add up, you get a 0, you're good. All right, now the next column is x minus x bar square, which is -3 square, so that is 9, and a -2 square, which is a 4, and a 0 square is 0, 2 square, which is a 4, and a 3 square, that is 9. So you add them up, you get a 26. Okay, so 9, 4, that's a 13, and there's another 13. All right, now if we want to measure like how far those numbers are away from the mean, see here is a 3, here is a 2, so you have a point here, you have a point here, right? You have a point here, and a 6, you have a 7, and you have an 8. See, that's all your points. And then we know the center is right here. Sorry, it's right here. That's a 5. And I want to know how far those data is away from this mean. So what I did is to find the difference. Sorry, did you see the difference? 2 and 5, 3 and 5? That's this column, right? Okay, however, just add up those differences. You're going to get a 0, so it won't help you. It won't explain how far those data, those points are away from the mean. There are two ways to solve this problem. The first one, I think it might be easy for you to remember, is take absolute value. So if you get all the differences, you take the absolute value of it. Then you get a 3, 2, 2, 3. Then you add up, and then you can average those numbers. There's a one way to do it, right? Absolute value. The other way is to square it. That's what we're doing here. This is a little better. I believe this is better and is more frequently used method to square the differences, because if the difference is small, when you square that, the value is small. If the difference is greater, no matter it's positive or negative, the absolute value is greater, you square that, it gets even greater. Okay, see, here's a 2, 2, 3, and a 3, but here you get a 4, 9, and 9. So it gets even greater, kind of enlarge the value of the point away from the mean. So I like this is better. All right, now once we have the summation of x minus x bar square, which is top here, so s square in this case will be, the top is 26 divided by, the denominator is n minus 1. In our case, n is 5, so 5 minus 1, so we have 26 over 4. Okay, so that is 6.5, and that is my variance, the sample variance. All right, just by looking at this, you probably still don't know the meaning, but the next step, you're going to use the calculator. You're going to use a calculator. You're going to use calculator to find the square root of 6.5, square root of it, which is s. And that is a 2.55. Well, this is a variance, sample variance, and this is sample standard deviation. You can see 2.55. That's in certain way to show the average distance of each point away from the mean. So that's called a standard deviation of this data set. And this is a way, every time when I give you like a list of numbers, and here is how you get the variance, and once you have the variance, you take square root of it, you get the standard deviation. So I hope this can explain like how do you get the get the sample variance and the sample standard deviation. If I give you a population data, then you have a capital N, and the only difference that you're going to use different letters, which is a sigma square, and here you can just divide it by 5 and then keep going. And to get a sigma square, that is the population variance, and you square root of it, you get a sigma, which is the population standard deviation. All right, now, so those are the most important one, 10 to 1. So if you see this again, you can just go back and repeat all the steps, what I do here. The numbers I give you are fairly easy, and there are only 5 numbers. If you look at my slides, that I might have like I think I have like 11 numbers or something, and the calculation is a little bit more complicated. It's not as simple as this one. I tell you a little trick that can save you little time is when you use your calculator to get the difference from this for this column. Say you get a 2 minus 5, you get a negative 3. Instead of finish this column first and go to the next column, you can just square it right away. That will save you time to enter these values. You get a negative 3, and then you square it, you get a 9, so you can write 9 immediately. And then you keep doing the next one, keep working on the next one and next one. So instead of doing by the second column, the third column, you can finish this 2 and then do this 2 and do this and do this. Okay? And sometimes there is an easy, some people call that a shortcut, which is if you have x and then you get x squared. Okay? So let's see the numbers. We have 2 and a 3 and a 5 and a 7 and a 8. All right, now the summation of x equals 25. Now x squared, instead of finding the difference between this guy and the mean, we can just square the number directly. So I get a 4, I get a 9, right? 3 squared is 9, 5 squared is 25, 7 squared is 49, and 8 squared is 64. Now I'm going to add all those numbers up. So there will be 1, and then I'm going to put 3, so 151. All right, so I have sigma x is 25, and the sigma of the x squared is 151. Okay, now the shortcut formula look like this. S squared equals n times the sigma of x squared minus sigma of x squared over n minus 1. I don't know if you like to remember this formula. I still prefer you remember this because that tells you the general idea about how to get it. But this one is just in terms of a calculation. It might be easier to do that on the computer. If you have if you do programming, it might be easier. But let's see, 5 times and a sigma of x squared, which is the sum of here, so that will be 151, minus a sigma of x, which is 25 square, right? And then divided by n is 5, so it's going to be 5 times 5 minus 1. Okay, 5 times 151, that's 755, I'm sorry, 25 squared is 625. And the denominator is 5 times 4, which is 20. So 755 minus 625, I got 130, divided by 20. So it's also 6.5. So we get the same answer. You should, either method you use, you get exactly the same answer. This way, if you like this way better, there's nothing wrong with it. You can just go ahead and do it. If you like this way better, that's totally fine. In the quiz, I don't really care which method or which table that you're going to complete. At least you finish one and you give me the right answer, you're good. All right, so we did mean, median, mode for the measure of center, and for measure of variation, we did a range, we did a standard deviation, and the variance. All right, now the others are not too bad. I probably just quickly go over that. And remember the third one, we talk about the absolute value, right? So it's called MAD, MAD, and that is the sigma of each x minus the x bar. You take the absolute value of the differences, you add them up, then you divide it by n. All right, so you don't really need to, I'm not going to, I probably do that. Okay, so I have x, 2, 3, 5, 7, 8, okay, and I have a sigma x is 25, x bar is 5, and then x minus x bar, if I take the absolute value right away, so it's going to be 2 minus 5, negative 3 square, absolute value, so 3 and then 2 and a 0 and a 2 and a 3. So the summation will be 10. So MAD in this case, that will be 10 over 5. So the answer is 2. Okay, so this is the way to calculate that. It's fairly straightforward, so I'm not going to talk too much about that. All right, now the next concept is called a CV, and it's called a I need to write this. That's mean absolute deviation. When I say absolute, that means you take the absolute value. Okay, so that's what MAD stands for. And the CV stands for coefficient of variation. Okay, the formula is a CV equals S over X bar times 100. Or the CV for population could be sigma over mu times 100. Okay, so this is for population. Okay, what is this? Quickly, we just go over the data. We have a 2 and a 3 and a 5 and a 7 and an 8. Remember for this data set, and we have this X bar is a 5, and we have S, we just did it a little earlier, is 2.55. Now, what is the CV for this data set, which is the standard deviation 2.55 over 5, right, over X bar, then times 100. So the answer is 51. Okay, what does that mean? All right, now let me give you another example, another data set. I got 102, 103, 105, 107, 108. All right, now this X bar will be, you add all those numbers up, divided by 5, it's going to be 105. However, for standard deviation, it's going to be every single number minus 105. You see the difference is the same as what I have in the previous table. You square that, you also get a 94049, and then you add them up, you still get 26, then you divide it by 4 minus 1. So you still get a 6.5, right? Okay, and then, but in this data set, your CV will be, sorry, this is S squared and S is 2.55. You get the same standard deviation. So that will be 2.55 over, okay, it's not 5 now, it's 105 times 100. So the answer is, I use my calculator to get it quick. So it's 255 divided by 105. So I get a 2.43. All right. Now, this and this is a big difference. Okay, what it says is, if you have the data set here, so 0, here's a 100, okay, and here is, maybe here's a, okay, so if you have all the data set around here, and the data was scattered in this range, and the other one is somewhere about here, okay, so same standard deviation, this S and this S, the standard deviation is the same. However, because the mean is very different, it's a 5 and a 105. So the standard deviation related to the mean, or the ratio of that to the mean, tells you something. All your data, they're around 105. In that case, if you have a standard deviation 2.55, it's not that much. We can still think all the data was pretty centered at 105 with a small standard deviation, relatively, right? But this one, because all the data are around 5 and you have the standard deviation 2.55, to get the CV is much, much greater. So you're going to say, wow, we have all the values are fairly small, but the standard deviation compared to the mean is relatively large. That's what is a CV stands for. Okay. All right, now the next one, the number 5 concept, or number 5 thing you need to know, is called empirical rule. Empirical rule says this: for a bell-shaped distribution, or we say approximately normal, which means a symmetric plus bell-shaped. if you have this type of distribution, then several things you have to remember. About 68% of the data are between 1 standard deviation of the mean. That means, for example, if we have the sample data, so we have the x bar minus standard deviation and x bar plus standard deviation, which is, if here is x bar, then we go this way by 1 standard deviation. Okay, so we minus as we get here, and we plus as we get here. So in this interval, we have about a 68% of the data. That's what it says. All right, now the next number. It's approximately 95% of the data are within 2 standard deviations, 2s of x bar, which is x bar minus 2 standard deviation and x bar plus 2 standard deviation. So if you look at this one, so it's going to be 1 standard deviation, 2 standard deviation up to here, so minus another one. So in this interval, we have about 95% of the data. Okay, and then the last one is 99.7%. That's going to be between x bar minus 3s and x bar plus 3s, which means, okay, if you go a little bit wider, another standard deviation. So in this interval, okay, we have roughly 99.7 of the data, but almost like all the data will fall within 3 standard deviations of the mean. So from the mean, if you go down by 3 standard deviations, and if you go up by 3 standard deviations, it contains almost all the data. Okay, just like around 0.3% data are outside of this interval. So this is the empirical. Remember that works with almost normal, we say symmetric and a bell-shaped distribution. Okay, there's another one, very similar, but the requirement is not that strong. Okay, it's called Chebyshev's. Chebyshev's. It's a Russian mathematician. In this way, I don't really care about the distribution. So it doesn't have this symmetric bell-shaped, it doesn't really matter, whatever distribution. And they said at least 1 minus 1 over k squared, this much of data should be between x bar minus k standard deviation and x bar plus k standard deviation within k standard deviations. Okay, so what happened when k equals 1, then this is 1 minus 1 over 1, so 1 minus 1 is 0, so it means at least some data are within 1 standard deviations of the mean, so we don't really care about that. So we care about when k equals 2 and when k equals 3. Let's see what happened when k equals 2. Here's a 2 squared, which is a 4 in the denominator, 1 over 4, and 1 minus that is a 3/4. So I would say greater than or equal to 75%. You see that, right? 3/4 is 75%. That's exactly this. I just use percentage to show this proportion. So at least 75% of the data are between x bar minus 2 standard deviation and x bar plus 2 standard deviation in this interval. And when k equals 3, all right, so 3 squared is 9, and 1 over 3 squared, which is 1/9, and 1 minus 3 squared is 8/9, which is 89.80. I just say 89% because I barely have space. So I would say at least 89% of the data are in this interval, minus 3s and x bar plus 3s. Of course, as a mathematician, they can go ahead and try to prove it, but we don't really ask you to prove. So you're going to be okay with this. Just remember this formula for Chebyshev's theorem. All right, now we did 1, 2, 3, 4, 5. There are 5 important concepts. Actually, the 2 has 2. The first one is range. The first one is the range. Sometimes we use that. And then the second is the variance and standard deviation. This is the most important, okay? So you're going to write down the formula, you copy that on your piece of paper, or that's your cheat sheet, and then maybe you copy this little table, or this table, the formula, and then you know how to calculate that. And then number 3, we learn what is MAD, we learn what is a CV, and then we learn the one empirical rule and the Chebyshev's theorem. So those are the 6 important concepts when we talk about the variation. All right, now you can just go ahead and to work on your homework.